All right, welcome back, everyone. We want to do a couple more examples involving these difference in sum identities. So here I want to find the exact value of cosine of theta minus pi over 3. I happen to know what the value of sine of theta is. I also know that the angle theta happens to be in quadrant 2. So now let's see what we can do to find things out here. First thing, if we're looking for cosine of theta minus pi over 3, using the identity that we had at the start of the last video, that would be cosine of theta cosine of pi over 3 plus sine of theta sine of pi over 3. Now, if we're thinking about what we have and what we don't have, we've got some of these things already. Cos of pi over 3 and sine of pi over 3, we can find those values using the special triangle that we have here. Sine of theta, we already know, that's equal to a third. So the only thing that we need to figure out before we can go further is what is cosine of theta. So I'm going to do that on the next slide, and then I'll backtrack and do our calculations. So we want to know what cosine of theta is, and here I'm going to use the fact that I know, using my Pythagorean identity, cosine squared theta is 1 minus sine squared theta. And since sine was a third, sine squared would be 1/3 squared, which is 1/9. So cosine squared theta is 8/9. So for cosine of theta, that should be root of 8/9. And the question is whether it's positive root or negative root. This is where we go back and remind ourselves we were told that the angle theta is in quadrant 2, and in quadrant 2 sine is positive but cosine would be negative. So that means we should be taking then the negative root of 8/9, which if we were to simplify that, the denominator 9 square root of that is 3, and the numerator square root of 8, that could be simplified as 2 root of 2. So cosine of theta should be negative 2 root of 2 over 3. And then all we need to do is just finish things off. We now know what cosine of theta is. That's negative 2 root 2 over 3. We know what cosine of pi over 3 is using our special triangle. We know what sine of theta is. We were told that. And we know what sine of pi over 3 is, again, using our special triangle. And now just to put everything together, we'll have negative 2 root of 2 plus root of 3 whole thing over 6. And there we go. We've come up with our exact value for cosine of theta minus pi over 3. All right, let's do another one. Here I've got two angles in quadrant 1, alpha and beta. So since we're talking quadrant 1, we know everybody is positive in this quadrant. Sine is, cosine is, tangent, and everybody else. We know the value for sine of alpha and cosine of beta, and so we can use those to find the values of cosine of alpha and sine of beta. I'll do a similar sort of thing that we did before. We know that sine of alpha is 3/5, so cosine squared alpha is 1 minus sine squared alpha, or 1 minus 3/5 squared, or 9/25, which when we simplify that, we get 16/25. And when we're taking square root, we know that it's going to be the positive root because, of course, we are in quadrant 1. Cosine is positive there. So cosine of alpha should be 4/5. I'm just going to write that down here, and then we'll do the same thing to find sine of beta. We know cosine of beta is 12/13, and sine squared of beta is 1 minus cosine squared of beta using our Pythagorean identity. Cosine squared was 12, cosine was 12 over 13, so cosine squared would be 144 over 169, which is 25 over 169. And when we simplify, we can find out what sine of beta is by taking square root. And again, positive square root because we are talking about angles in quadrant 1, and those angles would be positive angles. So we've now figured out for ourselves what are the values for sine of alpha, cos of alpha, sine of beta, and cos of beta. And the reason I was doing all of this is because we are going to be finding tangent of alpha plus beta. And knowing our formula for tangent of alpha plus beta, we'll need to know what tangent of alpha is and also what is tangent of beta. Now, easy enough for us to do because we know that for tangent of alpha, that would be sine of alpha over cosine of alpha. And since we've calculated both of those, sine of alpha is 3/5, cosine of alpha is 4/5. 3/5 divided by 4/5 is 3/4. And similarly for the next one, for tangent of beta, we know that tangent of beta should be sine of beta over cosine of beta, and that is 5/13 divided by 12/13, which is 5/12. All right, so the only thing left for us to do is to now find out what is the value of tangent of alpha plus beta. And that's easy enough for us to do because if we're looking for tangent of alpha plus beta, remember back to our formula for tangent of alpha plus beta, that this would be tangent of alpha plus tangent of beta in the numerator and 1 minus tangent alpha times tangent beta in the denominator. So let's get ourselves going. We want to find tangent of alpha plus beta. And that's tangent of alpha plus tangent of beta over 1 minus tangent of alpha, tangent of beta. And now we just have to put in everything that we found, because in the previous page we found that tangent of alpha was 3/4, and we found that tangent of beta was 5/12. So we'll have 3/4 plus 5/12 over 1 minus 3/4 times 5/12. And then the only thing left for us to do is just simplify. And then just evaluating 3/4 plus 5/12, that's 7/6. 1 minus 3/4 times 5/12, that's 11/16. And then simplifying, we get 56/33. All right. Now, some establishing of identities. This is the same sort of thing we did in the last section. We have the identity cos of pi minus theta is equal to negative cos of theta. And remember, when we're establishing an identity, we start with one side and show that we can transform it into the other side. I'm starting with cosine of pi plus theta, and that's because I know that I could apply the sum identity for cosine. Cosine of pi, cosine of theta, minus sine of pi, sine of theta. And then now I just can do a little bit of evaluating. I know what cosine of pi is. That's -1. And I know what sine of theta is. That's 0. And then just to simplify that, 0 times sine of theta, that is gone. So I'm left with just negative cos of theta, which is the right side of my equation. So therefore, left side is equal to right side. And I've established that identity. Let's do one more. We have this identity, sine of alpha plus beta over sine alpha sine beta turns into a couple of cotangents. Again, I'm going to start with the left side of my equation, because here I can see sine of alpha plus beta. I know I can apply that angle identity for sine. So that's what I'll do here, sine of alpha plus beta over sine alpha sine beta. I'll apply that angle sum identity for sine, and that is sine of alpha plus beta is sine of alpha cos of beta plus cos of alpha sine of beta all over sine alpha sine beta. Now, the next step here, if we're thinking about what to do next, remember that we're always looking ahead at where we're going to, and where we're going to is not a fraction, it's two terms added together, cotangent of alpha plus cotangent of beta. So that's giving me the idea here that maybe I should split this up. Instead of having one big fraction, I can split it up into two fractions. Sine alpha cos beta over that denominator, and plus cos alpha sine beta over that denominator. And then at that point, we can see a couple of things canceling. The sine alphas will cancel, the sine betas will cancel. And then what I'll notice that I have left is actually exactly what I want. Cosine over sine is cotangent, so that would be cotangent of beta. And this would be cotangent of alpha. So I actually have everything I need, because I would have that what we have here is equal to cotangent of alpha plus cotangent of beta. And so therefore we've shown that the left side can be transformed into the right side. So we've established that identity. All right, good work everyone. And this is the end of 8.5.